Hello everyone, let's talk about another easy problem on Leetcode today. Spatial array with x elements greater than or equal to x. In this, we are given an array nums of non-negative integers. Nums is considered spatial if there exists a number x such that there are exactly x numbers in nums that are greater than or equal to x. Notice that x does not have to be an element in the nums. Return x if array is special, otherwise return -1. It can be proven that nums is spatial and the value for x is unique. Okay, then they have given some example. So in the first example, we can see that there are two elements greater than equal to 2, and that's why we return 2 here. So I note that 2 is not part of this nums array. This is example 1. Now let's look at example 2. We can see that there are two elements which are all 0. Let's look at it. Why? If we would have chosen 0, there are two numbers which are greater than equal to 0. That's why it's not correct. It should have been 0 number greater than equal to 0. Then next case was x equal to 1. And again, we get there is no number greater than equal to 1 in this case, right? And similarly for 2 as well. And then in example 3, we can see that 04304 is the input array, and then output is 3, because if you look at it, there are three elements which are greater than equal to 0, which is 003. So now let's jump into the solution space. One of the brute force way can be that we can run it in two loops. So in the outer loop, we can loop on the numbers from 0 to n minus 1. And in the inner loop, we will check that whether this number exists in the array or not. The time complexity in this case will be O of n square, because we are using two nested loops. Now let's try to build upon this approach to make it better. In the first example, we can see that even though 2 was not part of the array, we still return 2 because there were two elements greater than equal to 2 in this case, right? Suppose we have this array. In this case also, we will just return 1, right? Because here we have one element greater than equal to 1. Now let's look at another example just for the clarity. Suppose we have 3, 4, 5 as an input. In this case, again, we will return 3 because like our output depends on the indexes or the range of the array. So that is, the output will always vary between 1 and n. Now that we have understood it, like now let's look at the how we can solve this problem. So indirectly, we are relying on count of the values which are greater than equal to 3. So one of the ways that we did in brute force was keep on doing the count check again and again. But an efficient way can be that we can actually sort the elements. So once we sort, what we can do is, like, suppose for us, we need x elements that should be greater than equal to x, right? So that is the idea. To have that, that means we need n minus x elements which are less than x, right? So that's the key point. So if our array is sorted, suppose we take the array as 1, 2, 3, 4, 5, right? So in this, there will be x elements, suppose from here, which are actually greater than equal to x. Say x was equal to 3 in this case. But there will be n minus x element, that is two elements, for example, which will be actually less than, strictly less than 3, or strictly less than x. So that is the pivot point we have to find. So the idea is simple. We will just sort the array. Then we will iterate from x equal to 1 to n, because we know that this is where the solution lies. And now what each x, we will try to select a candidate. We are calling it candidate because we don't know whether this is the real pivot point or not. So let's call it candidate. And then what we will do is, for each element, we will check if nums of n minus x is greater than equal to x, right? That is the first thing we have to check. And then to check the pivot, we should also check if nums of n minus x minus 1 is actually less than x. So that means we have found the pivot, and we will just return this element. If we don't, then we will just return, we will continue with the loop. And if we reach the end of the loop, we will just return -1. Now let's also look at this visualization. So suppose our input array is 1, 2, 3, 4, 5. And n is equal to 5 in this case, right? The length of the array. We will start looping. So x will be equal to 1. Then our candidate element will be 5. But we know that 5 is greater than 1 for sure. But 4 is also greater than 1. So that means we couldn't find the point where the pivot point yet. So we will just continue. And also we can see it with our eyes, of course, not programmatically, that there are 5 elements greater than equal to 1 in this case. So this is not our answer. Then we go to 2. Then we will check for the remaining n minus x element, that is like 4. In this case, is it more than 2? Yes, that's a good thing. But then 3 is also more than 2. So that, and we visually with our eyes also we can see that this is also not a pivot because there are 4 elements greater than or equal to 2. Now we go to x equal to 3, and now we get n minus x equal to 2, right? That means our candidate element is now 3. And is 3 greater than or equal to 3? Wow, that is true. But is the previous element to 3? This is 2. Is it less than 3? And the answer is yes. So we have found the pivot element. And also one more case that we have to handle. So let's look at example 1 again. So we can see that when num0 is already more than the length of the array, then like in this case 2, we already know that x is equal to 2, right? Because we already have n elements which are more than equal to n in this case, right? So we will just return n in n, which is the length of the array. Once we understand the intuition, the code is very simple. So we will just do arrays.sort on numbers. So this will sort the array in the ascending order. First condition we should check is like which is like an edge case is like if nums greater than equal to n, num0 is greater than equal to n, then we will just return n in this case because all the elements in the array are greater than equal to n. Now we will just try to find this position of x such that we get this pivot point. And then what we will do is we will just say find this candidate point. We will just do n minus x. And if nums candidate is greater than equal to x, right? And nums candidate minus 1 is less than x, that means we have found this point. So we will just return x. Otherwise, if we reach the end of this array, we will just return minus 1. Let's run this code. Cool. Let's submit it. Awesome. Now let's discuss the time complexity in this case. So for sorting, it takes O of n log n time, all right? Because in Java, I think internally the arrays.sort function uses quicksort. And on an average case, the sorting time there is n log n. And then we loop onto this array, like on these n numbers again, right? Typically trying to find this candidate point. So that will again take O of n time. So the overall time complexity will be O of n log n. But can we do better? And in this case, given the constraints, actually we can. So first thing is because we are sorting the integers, we can use something like a bucket sort to actually make the sorting O of n time, but that requires some extra space as well. But in our case, what we also have is like there are only 1001 elements of because num size can be between 0 and 1000. So in our case, there will be only 1001 elements or buckets that we can use, and we can actually use the bucket sort algorithm to just replace our sorting algorithm. So what we can do is like we can say bucket sort, and then we can just pass nums to it. And now we can just implement our bucket sort algorithm. So the algorithm is very simple. Like we will just create a bucket sort function, which takes nums. And now we will just define our buckets there to say 1001 and define the buckets array. So this is what takes extra space. And now when we loop on array, we will just count the frequency of these numbers in these buckets. So we will just say, okay, buckets num plus plus. So this will take O of n time, right? And now we will define our index just to sort the nums array in place, right? So what we will do is we will loop on these buckets, and we will now start filling in these numbers in the bucket. So it will be, we will get like current bucket I, suppose. And suppose the frequency of say number was like in this case, like let's look at example 3. In this case, the frequency of 4 will be 2. So when we are filling the element, we will fill them sequentially in this nums array, and we will fill 4 2 times, for example. So j plus plus and nums index plus plus equal to I, right? Because that's the element we are filling, because the bucket key or the index is actually the value itself, and that's it. And now we have sorted the array, and let's run this algorithm. Let's run the code again, submit it. So as you can see, it's actually even slower, and the reason for this is like because this array is very small. So maybe bucket sort, even though it looks like O of n in terms of time complexity, it does not help us much because the number of buckets in it are like 1001, which is way more than the array length. So yeah, even though asymptotically it should have been faster, but when we run it, given the constraints, it becomes slower. I hope this video was useful to you. If it was, please like and subscribe. Have a nice time.